This is a continuation of the Chapter 11 review, beginning with problem 7. And in problem 7, it's a little different than the other problems. Here, we're given the area of a sector with a central angle of 50 degrees. And we're asked to find the rest of the area of the circle. So it looks like this is going to require a little bit more room. So I'm going to go ahead and clear the board, and we'll begin looking at problem 7. What we have is a situation where we're going to have to find, well, there's several ways to do it, but I think the primary way is to find the area of this circle and then subtract off the area of this sector. Now, in order to do either of those, we're going to need this radius, and we don't know that right now, but I think we can find that given the central angle and the area of the sector. Let's go ahead and put down the area of the sector formula. Area of a sector is to the area of the circle as the central angle is to 360. Now, they give us the central angle and they give us the area of the sector. 27.93, the area of the sector, is to the area of the circle. The area of a circle is pi r squared. The central angle is 50 degrees, and we have 360 as the number of degrees in a circle. Now we need to solve for r. So I need to get rid of everything else on one side and solve for r on the other. So I'm going to go ahead and just multiply by r squared. 27.93 over pi equals 50 r squared over 360. That's 50. Now, I'm going to go ahead and multiply by 360 and then divide by 50 to get rid of these numbers so that I have an r and only an r on one side of the equal sign. So let's go ahead and go back up here, and we get 27.93 times 360 over 50 pi, because we divided by 50, equals r squared. Now, to undo the squared term, we square root both sides. And this will give us our r. So r is approximately equal to 8 to 3 decimal places, 8.000. So that's our radius. Now we can go ahead with the rest of the problem. Our target area, so we'll call it area target, is the area of the circle minus the area of the sector. Well, the area of the circle is pi r squared, and r is 8, so 8 squared, minus the area of the sector, which is 27.93. When we put that in our calculator, our target area becomes 173.166. Now, you should know that I didn't just use the rounded value of the radius. I actually used the stored value with all the decimal places. And so if you get a slightly different result, it'll be because you used 8 and not the actual stored value. But that is how you solve this kind of a problem. Let's go ahead and move on to problem 8. In problem 8, we have a kite, and we know it's a kite because it has two pairs of consecutive congruent sides. And so we know that the area of a kite is 1/2 d1 d2. You could also think of this as 1/2 the area of a rectangle that the kite would fit into. It works both ways, but it's 1/2 d1 d2, so it's a pretty straightforward formula. So it's area equals 1/2 d1 d2, and that stands for diagonal 1 times diagonal 2, 1/2 20 times 13, which is 10 times 13, which is 130. not really much of a problem, just a straight plug in. Now we go to problem 9. In problem 9, here we have a rhombus because we have 4 congruent sides. And the area of a rhombus is the same as the area of a kite. It's 1/2 d1 d2. So for this rhombus, it's 1/2 d1 d2. And d1 is 16, d2 is 12. So the area equals 96. Now let's move on to 10. For problem 10, again we're back to kite, and it's 1/2 d1 d2. So area equals 1/2 d1 d2, which is 1/2. d1 is 15, d2 14. Which gives us 5. All right, 3 fairly straightforward problems, just substituting in for the formula. Let's move on to problem 11. In problem 11, we're being asked to find the area of a regular polygon. Now, first thing we're going to do this is let's go ahead and write down the formula for the area of a regular polygon. Area is 1/2 pa, 1/2 perimeter times apothem. And if we want each of these, to find the apothem, we first need the center. We'll just say it's right about there. And it's always good to sketch a triangle. You only need one that has its base as one of the sides of the polygon. You don't have to draw on all of them. The apothem is that segment from the center perpendicular to one of the sides. So we've drawn in 2 radii and the apothem. Now we've got to determine what the length of that apothem is. Well, we know that this side is 8.8, and since these radii are congruent, I know that this is the perpendicular bisector of that base. That means this side is 4.4. I can determine the perimeter of my formula using this side length because it's just the sum of all the sides, but I still need this apothem. And in order to find that, I'm going to have to use some creative methods. I don't have any information of what the radius is. I don't know that side length. That's all I know is this piece. But I do know that this is a regular polygon, which means that all these triangles that I sketched, are congruent. And it happens to be a hexagon, so there's 6 of them. So I can find out what the measure of this angle is. And to find the measure of that angle, that's all I really need to do is take the number of sides and divide it by 360. Because there's 360 degrees in a circle, and there's 6 of these angles. So 360 divided by 6 gives us the central angle. So central angle equals 360 divided by the number of sides. That's supposed to be a d. And in this case, it's going to be 360 divided by 6, which, of course, is 60 degrees. That means that each one of these angles up here is 60 degrees. So this whole thing is 60. Now, if this whole thing is 60 degrees, and this is a bisector, it's a bisector of the side, it's also a bisector of that angle. That means this angle has to be a 30-degree angle, which makes this angle a 60-degree angle. And now that I know that this is a 30, 60, 90 triangle in here, I should be able to find the length of that side. Now, just to remain clear, I want to redraw this triangle because it's a little small. I'm going to draw it over here and put in my information. I know that this is a 60-degree angle. This is 90. This is 4.4. And this is 30. Now I can go ahead and label my sides. I know that this is A, this is 2A, and this side is A square roots of 3. So if this side is A square roots of 3 and A is 4.4, then this height, the apothem, is simply 4.4 square roots of 3. Now I have enough information to find my area. And I can say the area is 1/2 the perimeter. The perimeter is 8.8 times 6. 8.8 times 6. So that's 1/2 perimeter times the apothem. And the apothem is 4 square roots of 3. Or 4.4 square roots of 3. And this expression gets us our area. And if we put that into our calculator, we get 201.2, rounding to 1 decimal place. Now let's just say, just for kicks, that you forgot the 30, 60, 90 relationships. You can still revert back to your trig functions. We can either use the 60-degree angle or the 30-degree angle, and we can say some old horse, no, caught a horse, no, taking oats away. So we could find the apothem using tangent, and it would have been tan 30 equals taking oats away. So it would have been 4.4 over apothem, multiplying by apothem, a tan 30 equals 4.4, dividing by tan 30, the apothem equals 4.4 over tan 30. And that would come out to approximately 7.621, which is just about the same as 4.4 square root of 3. So you could have done the same thing, gotten your apothem using trig functions like this if you had forgotten your 30, 60, 90 relationships. All right, let us move on to problem 12, and given the time, we'll go ahead and do so in the next part. So I'll talk to you in the next video.